Hey everybody, and welcome to Lab 5 in Physics 1105. Okay, so Lab 5 is a formal written lab, so you're going to be doing a write-up. And so I'm going to give you a little intro, and before we start, I want to tell you what you're going to need out of your lab kit and what you're going to need to provide on your own. So the first thing you're going to need is your spring scale, okay? So you can see here, it's in a box maybe. Some of you may not have it in a box, but it looks like this. The camera's being weird. There we go. Can you see it? Okay. And it measures in either grams on, you should have a gram marking on there, or newtons. Now, as you're going to see, it's often good to just use grams for everything and not have to multiply everything by, convert everything to kilograms and then convert it to newtons by multiplying by G. So you can use grams for everything, and I'll tell you why. And that's because the other thing it uses is your mass set, which looks like this. And actually, maybe some of you have one that doesn't quite look like that, but inside are a set of slotted weights. This virtual background is not helping me out at all here. Okay, here we go. There we go. See that? And each of these is in grams as well. So when you're measuring forces with the spring scale and you're using your weights, right, to add weight to your setup, you're going to see this in a second. It's often useful just to not convert everything. But if that's confusing to you, just convert your grams to kilograms and then multiply by G to get newtons for everything. And then everything's in newtons, but you can do it either way, whatever is easiest for you. Okay, so let's look at the lab manual. All right, you're also going to need some string, by the way. Yes, string. Okay, so, and it can't be stretchy string. So try to use some string that doesn't stretch. Okay. All right. So I'm trying to get to the actual manual. Here we go. Okay, so what do we need? Well, yeah, you might need thumbtacks or nails. I don't think you actually need that, to be honest. Oh, I'm sorry. I should have told you that you also need your protractor and ruler, right? Some tape, maybe, string. Okay, it doesn't even say string on here. Anyway, oh, there it says string. Okay, so if we look, the idea is to make a setup that kind of looks like this. So you may have something else, but you can notice here that I've taped a marker here to hold things, right? I've taped a marker to a table. I mean, any way you can make this work, it's fine, right? Because what you're going to be doing is setting up this kind of like a little triangle almost, right? So you're going to set up a spring scale along one leg of this triangle. Okay, it's not really a triangle, but right, this kind of Y formation. And then you're going to put your masses, hang your masses down here. And then you have one string, right? It doesn't have a spring scale, but you have a string here attached over here. All right. So if we think of this from the point of view of forces, right? All the forces on this point right here have to add to zero, right? So if we think about vectors, that means the Y components have to add to zero and the X components. Now, what's Y and X? Well, the easiest thing to choose is, X is horizontal and Y is vertical. There's actually can be an easier thing to choose, and that is, remember that the coordinate system is completely up to you. So you could also choose that the Y component, the Y axis is along this or along this, and then you just need to make your X axis perpendicular. That can get a little tricky, so it's up to you again, what you want to use, what you think is easiest. All right, so here's the idea. You're going to set this up, and we know that all the forces on this point right here add to zero because this thing is not moving, okay? If you set it up and it starts, heading towards the floor, then you haven't set it up right. You have to get everything balanced, and it can't be moving. Okay, so all the forces sum to zero. So there's two things you're going to do for this lab. One, you're going to make a graphical representation of all the forces, adding them vectorially. Remember that vectors add tail to head. So if you were to figure out, so if you notice here, right, you have a force here that's being read by this spring scale. Again, the spring scale has a Newton scale and a Graham scale, right? The Newton scale is a little harder to read, but certainly I can see here that this looks like to me that this is 0.8 newtons from this picture, right? And then you know exactly how much weight is hanging down here, right? So you know that force. What you don't know is the force along this wire, the tension force along this wire, and that's what you're after. But if you know that all three of those forces have to add to zero, that means when you add the forces tail to head, right? So this force, and then you put this force on its tail, and then whatever closes that triangle of forces must be this force. Okay, so the first thing you're going to do is you're going to measure all the angles, write down this force, write down the force of this, but measure all your angles of these two lines here. This one's vertical, right? But these two sides have angles that you can measure with a projector. Okay, then you're going to get a piece of paper and you're going to figure out a scale, all right? So this is 0.9 newtons. You might want to make 0.9 newtons be 9 centimeters, right? So, right, that would be 0.1 newton per centimeter. It's up to you. The bigger the piece of paper, the better, and you can tape multiple pieces together. It's just easier if it's bigger than smaller. You're going to make less mistakes. Anyway, and then you're going to draw out the forces on the paper with the right angles, right, to make a triangle that closes, right? Because this unknown force will be the closing of your triangle. Okay. Once you do that, you can measure how long this force is, right? So how much, what the magnitude of this force is by measuring on your paper how long that vector is and converting back to newtons from your scale. And you can also measure the angle. Okay, so that will be your accepted value. And the accepted value will have some error in it. And that's explained in the analysis section of the lab. So let's go to the analysis section. So the graphical part is what I'm talking about here. Okay, so, so you will get your accepted answer for that unknown force with some error. And if you feel that it's hard to figure out what the error is, just keep reading. Okay. So, and then there's an analytical answer, right? So you have two forces that you know already. You know, the one from the masses hanging down, you know, the X component and the Y component. You know, the force along that spring scale, you know, the X component and the Y component because you've measured the angles, right? You can use your trig functions to get that. And so now you can find what is the X component of the unknown force and what's the Y component of the unknown force, because the X components have to sum to zero and the Y components have to sum to zero. And you can get the error for all that. There is a detailed example of how to get the error for the X components and the Y components down here. Okay. Then once you're done with that, you can compare using the null hypothesis. Did your analytical answer match your graphical answer? Okay. Again, one of my big tips is to make your scale big enough, you know, tape some pieces of paper together, get a big table. It's just much more accurate and easier if you make your scale bigger. I've seen students try to make their triangle, you know, this big, and it's so much error to do that. It's not going to work out. And be really careful with your drawing and your measurements. Okay. So again, this is a formal lab report. So hopefully you'll have some experience doing that from lab 3. And then you can write all this up. Make sure you include a picture of your graphical treatment, right? And if it's a big piece of paper, you might have to stand way above it to take the picture. Okay. So I think that's all I need to tell you about lab 5. Of course, there's a pre-lab as usual. The pre-lab uses a simulation for adding vectors. So that's a really nice simulation. If you're just like, what is she talking about adding tail to head thing? You can use it to practice that. Okay. So you can practice with your adding tail to head on that simulation and get a good idea of what I was talking about in the graphical way. Okay. Hope this helps, and good luck with this lab.